Okay, Year 12. We are starting today this little topic called simultaneous linear equations. And I want to explain right from the start really quickly what it's about. So the sorts of questions that you'll get in the end about this will be if you draw or you're given a drawing of two straight lines like this, if this is an x and a y axis, working out what value of x and what value of y makes both of these equations true. And that's what we call the solution to a pair of simultaneous equations. So just remember that is driving us for these 3 lessons or so. It's about 3 lessons, maybe 4, and it is in the assessment task, so that's why I thought you'd better start it today to get through it. So I'm going to use the textbook up here as we talk. So the first lesson, what you're working on today, is actually about drawing linear functions. Looking at linear equations and how you can draw them. I'm not going to go too much on about that, but I will get into the example. So this is obviously from a Cambridge textbook, and I thought we'd better use that as a guide. So the first question, first example, draw the graph of y equals minus 2x minus 1. So that's the equation. Okay, they've got some solutions worked out for you. The first thing is, and I'll show you some other examples in a minute, you fill in a table of values. You don't need 1, 2, 3, 4, 5 points. They've got 5 points too, just to be safe. You probably remember from last year, because I should have said this at the beginning, none of this is new. This is all setting you up for what we're doing in this topic. If you take out those two, you've got 3 perfectly good points there. How do you get those points? You sub in x equals 0 into the rule. So it's minus 2 times 0 minus 1. Minus 2 times 0 is 0, minus 1 is minus 1. That's why minus 1 has been written in there. You do the same with the other ones. Then you put dots at 0 minus 1, 0 minus 1, 1 minus 3, 1 minus 3, that's there. And 2 minus 5, now you notice this time this is actually off the scale, but 2 minus 5 is here. And the line is what you draw through both of those. So that's sort of the first bit, drawing these, using a table of values. This is really important, okay, in terms of doing this in the past. Whenever I talk about this stuff, this is probably one of the most important things. Y equals mx plus c. You know, you might have heard of y equals mx plus b as well. So if you're going to write something in your book, this would be the most important bit. Y equals mx plus c or b. The m is the gradient. I bet you remember this. And the c is the y-intercept. That's a really big rule for this topic. Okay? Now, by the way, also called the gradient slope. So they use both words. At university, they actually use slope all the time. They don't like the word gradient. Okay? Anyway, so let's look at some questions using those two things. Oh, of course, remember, the gradient equals rise over run. So it's like a fraction most of the time. So, all right, so the next example just says draw y equals 3x minus 2 from a table of values. That means doing what we did before, plotting the points. And then find the gradient and y-intercept of the line and check that they work with the rule. So let's pretend you've drawn it like before, like that. What's the y-intercepts? It's always where it cuts the y-axis, minus 2. And what's the gradients? Now, this sometimes confuses people because they're never sure which points to use. It actually doesn't matter which points you use. You can see this one, they've used this point where those crosshairs meet and this point where those crosshairs meet. And between these two, what's the rise and the run? The rise is 3 and the run is 1. So rise over run is 3 over 1. So the gradient is rise 3 over run 1. It's 3. Now, the funny thing is, right from the beginning, look at the equation. Y equals 3x minus 2. You probably already saw from the very start that m equals 3 because m is the thing in front of the x when you're looking at y equals mx plus c. So this was just a confirmation question. It was checking that you actually get the gradient in front of the x, and you do. And check that you get, at the end, the y-intercept, and you do. So, let's use it. Let's sketch, this is example 3, 3y plus 6x equals 9 using the gradient and the y-intercepts. And that's what's happening here. So, if you want to sketch 3y plus 6x equals 9 using the gradients and the y-intercepts, how do you do it? Well, it has to be in the form y equals. So you have to rearrange it first. So you've got a fair bit of practice of this with equations, and it's part of our course in standard maths. Take away 6x, you're trying to get the y on its own, you're trying to get y equals, so take away the 6x, so it becomes 9 minus 6x. Then you've got to get rid of the 3, getting rid of times by 3, so you divide by 3. Now, when you're dividing them by 3, you actually divide both of them by 3. 9 divided by 3 is 3, 6 divided by 3 is 2. So it becomes 3 minus 2x. If you swap them around, you get y equals minus 2x plus 3. So it means that, because we're looking at it, comparing it to y equals mx plus c, you end up with the m is minus 2, the gradient is minus 2, and the y-intercept is 3. And without getting into it in too much details, you plot the y-intercept first, which, what did we say it was? 3. So you put a dot where 3 is on the y-axis. That's that first thing you draw is that. Remember, you don't have the line until you've drawn it. And then you have to minus 2 as a gradient. So how do you work that out? As minus 2. Gradient is rise over run. It's got to be a fraction. Minus 2 is minus 2 over 1. So that actually means that you rise minus 2 and you run 1. How do you rise minus 2? Well, guess what? You go down 2. That's a run, a rise of minus 2. And that's a run of plus 1. So you go across 1 and down 2 and get another dot and you join it up and it looks like this. So, a bit of practice getting gradient and y-intercept from an equation and plotting them. Next, built into this is parallel lines. Obviously those two lines are parallel, and you notice that the gradients are the same. So for parallel lines, you need to write this in your book. If the value of m is the same for two linear functions, straight lines, then the lines are parallel. Both of these equations here have a gradient of 2. Y equals 2x, so the gradient's 2. This is y equals 2x, so the gradient's 2. They've both got the same gradient. Why aren't they the same line? Because the y-intercept is different. That goes through plus 3, the y-intercept of 3. This one goes through minus 4 as a y-intercept of minus 4. So they're apart from each other, but they're still parallel. So you need to make a note of that somewhere. Oh, and then the questions. So the questions you can probably see on the textbook. I'll move the, well, I won't worry. So, well, I'll move this over here quickly. Have a look at that. So have a quick look at this. They're the questions I want you to work on in class on Friday. And just to come back to this, you can sort of see it on the TV rather than have to get your own device out, so you can stop it as you go. Okay, so some of them are pretty predictable. Some of them you don't need diagrams, some of them you need diagrams. But all of this is getting you ready for what I started with, drawing those two lines and working out where they intersect. And I really hope, getting at the end here, the ones I call enrichment, that a lot of you guys get up to 14, 15, 16, 17.